Welcome to Tectonic Nights channel. Building an LLM is a complex multi-step process that involves everything from collecting and cleaning data to training massive neural networks and fine-tuning their performance. In this episode 1 of How Are LLMs Built, we will dive into the first step, data cleaning. We'll break down the data cleaning process into its core components and walk through the process one by one using datasketch library. Before diving into compute-heavy processing, we perform an initial filtering step based solely on the URL. This helps us quickly eliminate fraudulent or inappropriate websites, saving time and resources for downstream tasks. Our sample data frame here consists of rows where each entry is a URL pointing to a Wikipedia page. To begin, we'll filter out URLs that contain specific keywords such as category, special, or user. While this is just an example, in real-world scenarios, we would filter out URLs associated with scam websites, adult content, or other undesirable sources. Once we have filtered the URLs, the next step is text extraction. Our goal is to extract only the main content of the web page, excluding elements like menus, headers, footers, and ads. For this task, we use Trafilatra, a powerful tool designed to efficiently extract clean and relevant text from the web pages. After extracting the text, we need to ensure that the content is in the desired language. For this, we use the fast text language classifier from CCNet. It allows us to perform document-level language classification. Next, for document-wise corrections, we remove machine-generated spam such as keywords, lists, or nonsensical text by filtering out documents with unusual lengths, high symbol-to-word ratios, or fewer than X characters, say 50. We also perform line-level corrections to further refine the data. This involves discarding lines in all caps, lines with only numbers or single words, editing short lines, removing lines with certain keywords, for example cookie, privacy policy, or advertisement. If the flagged lines represent more than 5% of the total document, the entire document is discarded. Finally, we tackle duplicate content using fuzzy deduplication. By applying minhash, we compute a sketch for each document and measure its approximate similarity with others. Documents with high overlap are removed, ensuring that a dataset is free from redundancy. Let's understand the concepts before diving into the code. The Jaccard similarity measures the similarity between two sets. It is defined as follows. Say we have two documents A and B. A has 3 words and B has 3 words as well. Number of words common to both documents is 2. Number of all unique words in both documents is 4. This means that the two documents are 50% similar based on their word sets. Instead of computing the Jaccard similarity directly, which can be computationally expensive for large datasets, we can use minhash to approximate it. We apply multiple hash functions, say 3 for this example, to each word in A and B documents. For each hash function, we find the minimum hash value for each document. This gives us the minhash signature for each doc. The Jaccard similarity is approximated by comparing the minhash signatures of the two documents. Specifically, we count the number of positions where the hash values match, divide by the total number of hash functions. Now let's go through the function in the code. A minhash object M is created with the specified number of permutations, which is the number of hash functions. The text is split into words and each word is hashed and added to the minhash object using m.update. The function returns the minhash signature for the text, and a new column minhash is added to the data frame where each entry is the minhash signature of the corresponding text. This calculates the Jaccard similarity between minhash signatures of the first and second documents in the data frame. The accuracy of approximation improves as the number of hash functions increases. Next is minhash LSH, locality sensitive hashing, which is an extension of the minhash algorithm that allows for efficient similarity search in larger datasets. It works by grouping similar minhash signatures into buckets, so that documents with high Jaccard similarity are likely to end up in the same bucket. This makes it much faster to find similar documents compared to comparing every pair of documents. We start by creating an LSH index to store minhash signatures. The threshold parameter controls the similarity threshold for grouping documents into the same bucket. The min-hash signature for all rows are inserted into the LSH index. Now we can query the LSH index to find documents similar to a given document. The results variable will contain the IDs of documents that are similar to the query document, based on the specified threshold. Then we add the index of the first row in the results list to the deduplicated indices. This row is considered the representative of the group of similar rows. The final data frame contains only the unique rows with near duplicates removed. Thanks for watching. I hope you enjoyed the video. If you did, check out my other videos in Pandas playlist. Don't forget to hit that like button, subscribe and ring the bell so you never miss out on future content.